I'm Beth.
And I'm Beth.
Welcome to Physics with Beth and Beth.
We're in that AP Physics 1 unit. We're talking about average speed. We're going to do 2 problems on average speed today. Now, if you were in math and you had 2 numbers to average and it wasn't a rate, you would just add them up, divide by 2. That's not how it's going to work in physics because this is a rate. So we're going to show you how to do these average speed. So I'm going to go ahead and write the formula here for speed average, and that's going to be total distance divided by total time. Okay, so we're going to need what that's going to look like. I'm going to break that up a little bit more. We're going to need the distance from our segment 1 plus our distance from segment 2 over our time from segment 1 plus our time from segment 2. Now, what am I talking about segments? I've kind of got 2 segments in this problem, 2 different things going on. The first part of the problem, I was going 15 meters per second for 1.5 hours. So they gave you time, but not distance. The second part, where it says, and then, there's your clue, is that we have a second. Now we're traveling 22 meters per second for 750 kilometers. So they gave you distance in this part, but not time. Now remember, all these word problems, you're looking at units. Units are your key on what they gave you. Kilometers is a distance, hours is a time, of course. So here we go. We're going to start on segment 1 and just dive right into this. On segment 1, we know we were going 1.5 hours. All right, I'm going to put that 1 over 1. We're going to do some dimension analysis here. It's just a big scary word in science for meaning get it in the same units. We're with seconds and this is hours, and you can't mix seconds and hours. You got to have it all in seconds. So we're going to say, hey, there's 60 minutes in 1 hour. And then we're going to say there's 60 seconds in 1 minute. Follow through with your units and dimension analysis. I know when you get on a physics test, you're stressed out, you're rushing. Time is never your friend on a physics test. But if you start dropping units, then it will cost you time and it will cost you points. If you follow through with your units, you know that you put, hey, was I supposed to put 60 on top? Do I multiply by 60 or do I divide by 60? You shouldn't ask that question. Write this out. It will take you 1 second to write it out. And then you know, hey, I know I multiply by 60 because now I have an hour on top and an hour on the bottom. They cancel out. I have a minute on top and a minute on bottom. They cancel out. And I'm left with my second unit. So now I know, oh, I was supposed to multiply by 60 and multiply by 60 again. I used to get that question a lot. Do I multiply or divide by 60? Write it out. Write it out with your units. Do a dimensional analysis and you'll know the answer to that. And then it will save you points on a test as well as time when you have to go back and go, that didn't seem to come out right. All right, now I have my time in seconds, so that's the first part, my time for my first segment, but now I need my distance for my first segment. So I know that I went 5,400 seconds. I'm going to put that over 1, and I say, hey, wait a minute, I know that I went 15 meters per second. For that whole 5,400 seconds, I went 15 meters for every 1 second. That's really what 15 meters divided by seconds means. That for 1 second, and remember that's not a 5, that's a second. Sometimes I start even putting an EC if I think I'm going to mix that up later on if I'm rushing. All right, I have seconds on the top, seconds on the bottom, cancel out, and I'm left with a meter. And look at that. I'm going to take 5,400 times 15, and I'm going to get 81,000 meters. I now have a distance for segment 1 and a time for segment 1. I'm going to now move to segment 2, and we're going to do the same thing. Only this time, they did not give us time. They gave us distance. So I'm going to take that 750 kilometers. I'm going to put it over 1, and I'm going to do a unit analysis again. Because look, I can't be in kilometers and meters at the same time. They have to be in the same units. So I'm going to do that dimensional analysis. 750 kilometers, there's 1,000 meters in every 1 kilometer. And I'm going to get 750,000 meters. There's my distance in segment 2. The only thing I need left is my time in segment 2, and then I can do my total distance divided by total time and get my average speed. We're almost there. So I'm going to do this. I know I went 750,000 meters. I'm going to put it over 1. By the way, my little dots mean that I'm multiplying. I just don't like to use X's. I like to use dots for that. Now, though, this 22 meters per second is saying this. You go 22 meters for every 1 second. Or you could say for every 1 second, I go 22 meters. So I need time. I'm going to put time on top. I went 1 second. In 1 second, I went 22 meters. You're like, whoa, wait a minute. 1 over 22 is not the same as 22 over 1. That is absolutely correct. If you're dealing with only numbers in math, it's like that. Don't try this at home. Don't try that in math with just numbers. But if you're talking about rates, you can absolutely do that. It's the same thing. 22 meters in 1 second, or in 1 second, I went 22 meters. So I'm going to put the meters on top and bottom cancel. And look at this, I'm left with seconds, which is what I want. I want time for this unit. So I'm going to take everything on top and then multiply everything on top, divide it by everything on bottom. So I have 750,000 meters divided by 22. And I'm going to get, 750,000 meters times 1 second divided by 22. And I'm going to get 34,090.91 seconds. I now have total time and I have total distance. So I'm going to go to red and I'm going to go right up here and just keep going. My distance for segment 1 was 81,000 meters. My distance for segment 2 was 750,000 meters. And again, this is why you want to keep your units in. You might have accidentally, if you're rushing on a test, pulled this number, which is seconds, 5,400 out for segment 1. So you want to keep your units. It will save you points and time in the long run, I promise. Now we're at time. On segment 1, I am at 5,400 seconds plus I have 34,091.91. That's 90, sorry, 0.91 seconds. And I'm going to get a grand total here of 831,000 meters over 39,490.91 seconds. I'm in meters per second, which is what I wanted. So that's going to give me, if I do that division, 21 meters per second. Look, if you add up 22 plus 15 divided by 2, you're going to get 18.5 meters per second. That is not what we came up with. Why? Why is that? Because look at our time. We went at a faster speed for a lot longer time. We were going 22 meters per second for 34 seconds, 34,000 seconds, which is close to about 9.5 hours. That you were going 22 meters per second, where we were only going 15 meters per second for an hour and a half. So just like if you were going down the road and you were going 70 miles per hour for 4.5 hours of your 5-hour trip, you are going to be closer to 70 miles per hour than that last half hour where maybe you went in the city and got stuck in traffic and were only going 35 miles per hour. So you would have a faster average speed. And we have a faster average speed because we were going way longer for a higher speed. We were going almost 9.5 hours at that higher speed. Now, could it ever be? Here's some logic when you're looking at these problems. If you get an average speed of like 24 meters per second here, that's not possible. Something went tragically wrong in your problem and you need to go back and look at it. Could you get something less than 15 meters per second? No, you could not. Again, tragically, something went wrong. Redo, abort, and redo. All right, because it needs to be between 15 and 22. It's got to be somewhere between these two numbers. Closer to 22 this time because we were just going at that faster speed for so much longer. Anyway, that's it. Happy physicsing, and I hope that helped you understand average speed. Happy physicsing, y'all.